So today we're going to be going through the practice problems for Open Up Unit 2, Lesson 3. So the very first thing that we're doing here, we know Noah is running part of a marathon, and he's going at a constant speed of 6 miles per hour. And of course we're going to be completing the table to figure out how far or how long it's going to take him to go to each of these intervals. So this tells us, and we always have time at the bottom, so it's always distance over time, or actually any time, anything that when we're comparing time should always go on the bottom of our ratio. Sometimes we do show it the other way, but the natural way is distance over time. So that's going to be 6 miles over every 1 hour. So, very conveniently, our very first one starts out with 1 hour, so we know that's going to be 6 miles. And they even tell us that here. While we're looking at this, though, let's remember when we go from left to right in our tables, we're always multiplying. In this case, we're multiplying times 6. And we go from right to left backwards, we're either dividing by 6, or you should know that that's the same as multiplying by 1/6. Of course, you can make your choice if you want to divide by 6 or multiply by 1/6, but ultimately, that to make it easier for you, you will probably be just multiplying by 1/6. So let's get started here. We've got 1/2 times 6. We know that means we're just looking for half of 6, so that, of course, is 3. Now, we've got this 1 1/3. So we've got a fraction. Well, really, we have a mixed number. 1 1/3 needs to be changed into an improper fraction. So 3 times 1 is 3, plus 1 more is 4. So that's 4/3. And we know we're always multiplying times 6 for these particular problems. So that's times 6. I can't have a whole number. I put it over 1. Keep the top with the top and the bottom with the bottom, so that gives me 24 over 3, because 4 times 6 is 24, and 3 times 1 is 3. I'm going to reduce this. 24 divided by 3, or 24/3, of course, is equal to 8. So the next one right here, miles traveled per hour, is 8 miles per hour. So now I'm going in this direction. So things are going to be changed up a little bit. We've got 1 1/2, and I know I'm dividing by 6. I'm going to do this one up here. 1 1/2 is a mixed number. I need to change that into a fraction. So 2 times 1 is 2, plus 1 more is 3. So I've got 3 halves, and I'm just going to go ahead and multiply times the 1/6. Because remember, we're dividing by 6, that would be 6 over 1. And first we will divide, keep the first, flip the second, so we'd be flipping it anyway to 1/6. Then we multiply. Keep the top with the top, 3 times 1 is 3, and the bottom with the bottom, 2 times 6 is 12. Last we will reduce, so I know that the gazinta that they share is 3, so I divide top and bottom by 3. 3 divided by 3 is 1, and 12 divided by 3 is 4. So this is 1/4 of an hour. That is a 4 there. Okay, next one. Again, we're going from right to left. So we're going to be dividing. So I've got 9 divided by 6. Now in this particular case, it turns into a fraction that I'm just simply going to reduce. So again, what's the gazinta they share? The gazinta they share is 3, so we divide both of them by 3, top and bottom by 3. 9 divided by 3 is 3, and 6 divided by 3 is 2, and that reduces to 1 1/2, which is what goes in here, 1 1/2. We're almost done with this problem. 4 1/2, again, divided by 6, it's a fraction. I'm going to, of course, multiply, just go straight to multiplying by 1/6. So 4 and 1/2. 2 times 4 is 8, plus 1 more is 9. So I've got 9/2 times 1/6. Keep the top with the top and the bottom with the bottom. So 9 times 1 is 9, and 2 times 6 is 12. The Gesinta they share, again, is 3. Divide top and bottom by 3. So 9 divided by 3 is 3, and 12 divided by 3 is 4. So the last one is 3/4. Okay. Next problem. We're told that 1 kilometer is 1,000 meters, and we have to complete both of these tables based on that information. So, right here we have 1 kilometer is on the right, but on this side it's on the left. So let's see how that changes things, because believe it or not, it does. So, I know in all of these I'm going from left to right, but the number is getting smaller. So if we remember, when the numbers get smaller, that means we're multiplying by a fraction. So in this case, we'd be multiplying 1,000 times what is equal to 1, or we simply divide to find out what that is. So if we divide, that'd be 1 over 1,000. Or you can also remember that that's the same as 0.001. That's in the thousandths place, so that's 1/1000th as well. So I know that what I'm multiplying by is one of either one of these two numbers. So in both cases, because there's 3 zeros or 3 decimal places, that just simply means that I'm going to be moving that decimal 3 places back or to the left. So in this particular place, or this particular one, I've got 250. The decimal, remember, I think about it like a period. It's always right at the end of my number, like the period is at the end of a sentence. And we go 1, 2, 3 back. So that's going to give me 0.25 or 250. You don't need the 0 in this case, but if you have it there, it's certainly not wrong. Now again, I've got the 12 decimal, just like a period at the very end of the number. I move my decimal back 1, 2, 3 places. Uh-oh, there's nothing there. We take that placeholder and replace it with a 0. So in this case, it's 0.012. And then the very last one, we're taking 1 and we're moving the decimal place back 3 places in that case as well. So 1, it's got the decimal at the end. 1, 2, 3. In this case, we need 2 placeholders. So it's going to be 0.001 is my answer. Okay, so now remember we're going in reverse. So in this case, to get from left to right, how do I get from 1 to 1,000? I'm still multiplying, but this time times 1,000. Now, you should remember that when you're multiplying by 1,000, I have 3 zeros. So this time I'm going to move the decimal not to the left, but to the right 3 places. So if I start with 5, that decimal is still like the period at the end of the 5. If I move it 3 places, 1, 2, 3, I put my placeholders in there, it's 5,000. I'm sure most of you probably knew that the answer was 5,000, but it's important to just remember the reason why. So 20 times 1,000, of course, is going to be 20,000. And 0.3, well, let's look at this one, 0.3. I move that decimal 1, 2, 3 places. So I only need 2 placeholders this time, and the last one is 300. What is the relationship between the two constants of proportionality? Well, remember, the constant of proportionality is just that fancy name for the number that we multiply by when we go from left to right. So in this case, the case on the left, this one right here, we multiplied each and every one of them by 1/1000th, or if you prefer the decimal form, it doesn't truly matter. So the constant of proportionality in this one was 1/1000. And in this case, again, when we went from left to right, we multiplied everything by 1000. So the constant of proportionality was 1000. Well, if I look at these two numbers, I should notice that they are, if I put this over 1, they are reciprocals of each other. And remember, reciprocal is just a fancy name for meaning we flipped it. Okay, next one. Move on. Jada and Lin are comparing inches and feet. Jada says that the constant of proportionality is 12, and Lin says it's 1/12. Do you agree with either of them? Explain your reasoning. Well, hopefully you realize that 1 foot is equal to 12 inches. So if you know that, the constant of proportionality is 12 if we go from left to right. We'd multiply everything times 12. So therefore the constant of proportionality would be 12. However, if we do it the other way around, and we start out with 12 inches on this side, equal to 1 foot over here, what do we multiply to get from left to right here? Well, if we're not sure, we know we have to divide in the other direction, so that would be 1 divided by 12, or 1/12, which is right here. So this is the constant of proportionality here. So therefore, that means that they are both correct. And we've shown why right here. Next problem. We have the area of the Mojave Desert. And they tell us that the area is 25,000 square miles. A scale drawing of the Mojave Desert has 10 square inches. So we went from 25,000 to 10. So remember, that number gets smaller when we go from left to right. So I know that I'm multiplying either by a fraction, or if I'm not sure what it is, of course I would divide, right? So in this case, I know that it's reduced from 25,000 down to 10. So how much was it reduced by? Well, the way that I would find that is I would divide 25,000 divided by 10. When I do that, I'm simply canceling those zeros, because remember, dividing by 10, I'm just moving that decimal back one place. So that means I've got 2,500 as the scale from one to the next. However, we know that it's area. So remember, area means we're multiplying a length times a width. So that means that 2,500, we have to find the square root of it, because we know that the width and the length were multiplied by the same thing, which gave us the 2,500. So 25, what times itself gives me 25? That would be 5 times 5 is 25. I've got 2 zeros. Well, that's easy enough because I know 10 times 10 would be that 100. So 50 is the answer that I'm looking for. 50 times 50 is 2,500. So this tells us that for every one, now we're not talking about square miles anymore. Remember, we're talking about the distance of the length and the distance of the width. Both of those were multiplied times 50 in order to give us this 2,500. So therefore, that's telling us that 50 miles in actuality is equal to 1 inch on the map. So that is the scale of the map. Uh-oh. Next problem. Which of these scales is equivalent to the scale of 1 centimeter to 5 kilometers? So for each and every one of these, we start 1 to 5, and we see if they share this same constant of proportionality. So for the first one, it's 3 to 15. How do I get from 1 to 3? I multiply times 3. 5 times 3 is in fact 15, so this one works. That is a correct answer. I start again with 1 over 5 equal to 1 over 150. Well, 1 times 1 is 1, and 5 times 1 is not 150, so that one does not work. The next one, I've got 1 centimeter to 5 kilometers is again where I'm starting, and this one is 5 centimeters to 1 kilometer. So of course I know that 1 times 5 is 5. 5 times 5 is not 1, so this one also doesn't work. Next one, got 2 more to go. Still using my 1 to 5 ratio to begin with. And now this one's a little bit more confusing because this one is in millimeters to kilometers instead of centimeters. So that does make it a little bit different because I need to know how many millimeters are in a centimeter. So it probably is a little bit confusing to look at this if we're looking at the centimeters to kilometers. So what we want to look at is converting those millimeters to centimeters. So hopefully you know that 1 centimeter is the same as 10 millimeters. So if I've got 5 millimeters, I would do 5 divided by 10, which means I'm moving that decimal back 5/10. It would be 0.5 to 2.5. Now, if I know that I'm multiplying to get from 1 to 0.5, I'm either multiplying by 1/2 or multiplying by 0.5. That is 1/2. So if I do the same thing here, find half of 5, that is also 2.5. So this one also works. Now the last one has got millimeters and meters. So I already know how to convert my millimeters to centimeters. I have to divide by 10, so that's 1/10. Or if I wanted to write that in its decimal form, it would be 0.1. And I've got 500 meters. So 500, or not 500, 1 kilometer, that's a 1 there, is equal to 1,000 meters. So that means I would take this and the 500, and I would divide that by 1,000. If I cancel out those zeros, I'm left with 5/10. Well, that would be 0.5, or same as 1/2. If I reduce that, 5/10 would equal 1/2. Same thing, 0.1 and 0.5. Is that equal to 1/5? Well, it sure is, because both of these have been divided by 10, because the decimals were moved back one place. So this one works as well. So the scales that are all equivalent to the original given are A, D, and E. A, D, and E. And that brings us to our last problem. Which one of these pictures is not like the others? And I'm sure by sight you can tell which one it is, but it definitely tells us to use ratios to compare them. So that means I think we should compare the height to the width of each of these. So the height of L, or the width to the height, it really doesn't matter. So let's do width to height for each of them. And I've got three shapes. I've got L, M, and N. So L, the width of L is 1, 2, 3, 4, 5 units. And the height of L is 1, 2, 3, 4 units. If I look at the width of M, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 wide over 1, 2, 3, 4, 5, 6, 7, 8 high. And for N, if I look at the width, I've got 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 wide. And the height, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 high. Now, in order to compare them, we need to, the best way to do that would be to reduce them, which means we're looking for the gazintas. So 5 and 4 don't share a gazinta. That's already reduced in its lowest form. For M, the gazinta, the biggest number that gazinta both of them is 2. Divide top and bottom by 2. 10 divided by 2 is 5. 8 divided by 2 is 4. Well, that's the same. So I know ultimately M is 5 to 4, just like L is. Now, we could stop here, but the wise thing to do is to carry on and make sure that we didn't do something wrong. The gazinta that 15 and 12 share is 3. So 15 divided by 3 is 5. And and 12 divided by 3 is 4. Well, now, if you're paying attention, this might be a little confusing. Why do they all look the same? Well, what we were comparing was the entire shape, where if we look at this, we probably notice that the interior width is what looks different. So let's now go back and compare that width to the height. So I'm going to do width over height, and I'm going to have shapes L, M, and N. So I've already got the height for all of them. So the height for L is 4, the height for M is 8, and the height for N is 12. So all I have to do is go back and find the width of the inside part. So for L, it's 1, 2, 3 across. So now I'm looking at a 3 to 4 ratio. For M, it's 1, 2, 3, 4 across. And for this last one, for N, it's 1, 2, 3, 4. Sorry about that. Let me start again with N. It's 1, 2, 3, 4, 5, 6, 7, 8, 9 across. So if I reduce each of these, L is already reduced because they don't share a gazinta, 3 and 4. 4 and 8 do share a gazinta, 4 gazinta both of them. So 4 divided by 4 is 1, 8 divided by 4 is 2. So that one's 1/2. And then my last one, N, the gazinta they share is 3. So if I divide top and bottom by 3, 9 divided by 3 is 3. And 12 divided by 3 is 4. Well, now it's clear that L and N are the same because we look at those ratios. They all match, all three of them match when we do the far width, but when we do the last one, or the center one, they don't. So therefore we know that L and N are the same ratios.